Alright guys, so part of the notes here, so percent composition, molecular, and empirical formula. Okay, so quite a bit of stuff, so let's get rolling. Alright, first off, percent composition. Okay, all that is you're just figuring out the percent by mass of any element in a compound. So first I'm going to take the mass of each element, multiply that times 100, and that's going to give me my percent whenever I take that and divide it by the total mass of the compound. Alright, so here's an example. Alright, so I've got to calculate the percent composition of water. Alright, so first thing you do is you take and figure out what's the mass of each individual element divided by the total mass of each of the total element. Right, so I've got 2 moles of hydrogen. Right, its mass is 1, so I go through the whole process of figuring out how many grams those moles are equal to, and then divide that by the total of water. Right, so for hydrogen it's 2, and then for oxygen it's 16. So I'd say 2 divided by 18 and 16 divided by 18, and that's going to give me my percentages there. So it ends up equaling 11.2% for hydrogen and then 88.8% for oxygen. So that's their percent composition. Alright, so pretty straightforward, not too hard really. All it is, and you're just figuring out each individual mass of the compound and dividing it by the total. Alright, empirical formula. Okay, a little bit tougher, but still going through the same process, right? So empirical formula is where I determine the smallest whole number ratio of the element. So here's an example, right? Determine the empirical formula for methyl acetate, which has a 48.64% carbon, 8.1% or 16% hydrogen, and 43.20% oxygen. Alright, so take my percentages, right? And I'm going to take those percentages and I'm going to go ahead and pretend like they're the grams, right? So I'm going to turn all those percentages, so 48.6 and 8.16 and 43.2, I'm going to go ahead and turn those into grams, right? And then I'm going to convert those grams into moles, right? So carbon's mass off the periodic table is 12, so I'm going to divide by that to get it into moles, so 4.505 moles. I'm going to take the 8.16 grams divided by the mass of hydrogen off the periodic table, so 1, and that's going to give me 8.10 moles of hydrogen. I'm going to take the mass, 43.20 grams, and divide it by the mass of oxygen off the periodic table, so 16, and that's going to give me 2.7 moles of oxygen. All right, so that gives me how many moles each of those results into. And then I'm going to go ahead and take all those, and I'm going to divide those by the smallest of those numbers. All right, so in this case it was 2.7. So I would take 4.05 divided by 2.7, 8.1 divided by 2.7, and of course 2.7 divided by 2.7. And that's going to give me my ratios. So my ratio ends up being 1.5 moles of carbon for 3 moles of hydrogen for every 1 mole of oxygen. Well, I want them to be whole numbers, so this 1.5 is not going to work. So what I'm going to do, instead of just keeping it as 1.5, if I doubled that, that would equal 2, or I'm sorry, 3. And so then I would need to double this, so 3 times 2, 1 times 2, and that's going to give me my empirical formula, which ends up equaling C3H6O2, right? So that gives me the whole numbers, and that's the simplest formula that would be methyl acetate. Okay, so that's how I find the empirical formula. Right. Now, once I get done with empirical formula, now we got to figure out the molecular formula. All right, so again, just another step further, but you're using the things that we've been learning. All right, so what that is I take the experimental molar mass, so whatever they give me in the problem, I'm going to divide that by the empirical formula's mass once I find that, and that's going to give me an n, or the ratio that I need to determine to multiply the empirical formula by. All right. So here's an example. Determine the molecular formula for a compound composed of 40.68% carbon, 5.08% hydrogen, and 54.24% oxygen, which has a molar mass of 118.1 grams per mole. So this 118, that's going to be my experimental molar mass. So now I've got to figure out the molecular or the empirical formula mass so that I can solve for n. So first thing I got to do is find the empirical formula, right? So take the percentages, remember, turn those into grams, okay? And then I'm going to go ahead and divide those by each individual mass. So here carbon is 12, hydrogen is 1, and then oxygen is 16, all right? and that's going to give me 3.387 moles, 5.04 moles, and 3.39 moles for each of those. Then I'm going to take those, right, divide each of those by the smallest number, which is 3.387, okay, and that's going to give me 1 mole, 1.5 for hydrogen, and 1 for oxygen. Well, again, I want it to be a whole number, so I multiply each of those by 2, so I end up with 2 carbons, 3 hydrogens, 2 oxygens. So the empirical formula here is C2H3O2. Alright, so now I have the empirical formula. So now I just need to solve what is its mass, right? Well, there's 2 carbons, so 2 times 12 is 24, 3 hydrogens, so that would be 3, and 2 oxygens times 16, so that's 32. Add it all up, and that's my empirical formula's mass, 59.04 grams. So now I have the empirical formula's mass. I can now solve for N, which it wanted me to do in the original problem. So yes, it's a little lengthy, but if you're writing it all down, it's not too difficult. So now I'm going to take that 118 they gave me in the problem originally, divide that by the 59.04 that I just found, and that gives me my N, or my ratio, of 2. Alright, so that's the molecular formula's number that I need to multiply by. So I'm going to multiply that times the empirical formula that I had originally, so C2H3O2, multiply that 2 all the way through, and my molecular formula ends up being C4H6O4. Alright, so this is the last bit of notes for this unit, so hopefully if you don't understand, review it, go over it again, and we'll be working problems in class. Alright, guys.